Hey guys, here I'm again. Sorry about that. I don't know what was going on with my computer, but it wasn't syncing the right way. I'm sure you guys might have heard me. I looked at the rebroadcast of that and it was working. About that, I don't know what was going on with my computer, but it wasn't syncing the right. So sorry about that. You got a bit of echo there. It wasn't syncing the right way, and so something was going crazy. So now I think I got it working. So if you are in my class and you want to ask a question about the exam that's coming up tomorrow, and sorry about this lighting is crazy in my office, and you want to know something about the test, you want me to do any of those problems that are on the review, just text me the problem number on Remind, and or you can do the comments. I think we can take a look at the comments here on the side. I think there's a group chat. So if you just enter that in the group chat, I can do the problems for you and we can talk about what's on the test. So I do have a few things I can talk about while I wait for some questions here from the audience. I have 4 viewers right now. At least that's what it tells me. It's probably more, but that's what it's telling me. So let me share my screen with you. And so hopefully you are seeing this OneNote page. And you're saying, yes, I'm seeing it. So here are a few things that you're going to need to make sure that you are able to do for the test tomorrow. You want to make sure you know how to use limits, how to determine limits using your graphing calculator. So what you're going to do is you're going to need to graph the limits or graph the function and then use the table to try to find where that limit approaches. So sometimes you can kind of figure out just by looking at the graph, but for the most part, you want to be able to do that using your graphing calculator and the table function. If you are, you could also look at the denominator, take whatever's in the denominator and solve and put that in your calculator. So you're going to put the denominator, whatever's in the denominator, you're going to put in your function as your function, and you're going to graph that function and find out where it crosses the x-axis. So that's going to create a vertical asymptote. So sometimes that's what you need to do if you're looking at possibly having a vertical asymptote. But if you're looking at just the limit, you're going to want to put the whole graph in there, and then you're going to want to look at the table and see what that value approaches, what the y value approaches on your table as you get closer and closer to that x value. So there's a couple of problems on the exam for that. You need to know how to write end behavior in terms of their limits. Remember that end behavior is just horizontal asymptotes. So if there are no horizontal asymptotes, then you're either going to positive infinity or negative infinity, depending upon how this gets plugged in. And remember, you just got to do a little bit of numerical analysis there. You got to kind of ask yourself, well, is the top going to be positive? Is the bottom going to be negative? Positive, negative? Is it going to go to negative infinity or positive infinity? Again, like I was explaining to some students today, positive infinity and negative infinity as your answers. You're really only going to need to be concerned about that on the multiple choice section, because if this was a free response section, you can put if the limit does not exist, if it goes to infinity or negative infinity, you could just put does not exist. So anytime you get a number over 0, that's going to go to positive or negative infinity. All right. These guys here, when they have infinities, those you're looking for the horizontal asymptotes. Use those rules that I went over: little over big, big over little, and when the powers are the same, you take the coefficients. All right. Make sure you know how to do the intermediate value theorem. I saw some of us working on the board today on the intermediate value theorem. There will be a problem with intermediate value theorem. This is good because I believe the intermediate value theorem was on Unit 1, so this allows you to get some of those points back from your Unit 1 test if you didn't get a perfect score in the Unit 1 test. So remember that you have to check continuity first, then you check to see if the value, the y value when you plug in, is in between those. So you got to plug in the x values to find if your y value where c is is in between there. That's the second check. And then if it asks you to find C, find C. All right. So a couple of multiple choice. There will be a limit definition of the derivative on the multiple choice. So you'll only have to do it a couple times, once on the multiple choice and then once on the free response. I would say use this. I don't know what that is. Use the one that is x plus h minus f of x over h, because that one is just a little bit easier to use. But if you like the delta x version, you can use the delta x version. It doesn't matter which one you use. They're both limit definition of the derivative, and I'll accept either one. So those are a few things just to keep in mind that will be on the test. There is curve sketching. There's piecewise functions, limits, all kinds of good stuff. And of course, there's power rule. So make sure you are good with your power rule. I would also recommend that you memorize your parent functions and memorize all that stuff that's in the Unit 2 summary. All right, so let me see if there are any questions here. Nothing on the group chat. All right, guys. So any questions? If you have questions, hit me up on Remind here. I haven't gotten anything yet. So if you want, I'll do a couple of problems. Like number 58. So really quick, can somebody just give me a yes or no that you were able to see my computer, my my work that I was going over just right now when I was sharing my screen? I think they're simple, but don't know for sure. Okay, 41, 42, 58, perfect. Okay, thank you, Krishan. All right, so oops, I see your name. Not that, I don't know if it matters, but here we go. Let's get going here. So I've got 58 and then 41 and 42, I believe someone asked about. So let's take a look at those. Okay, screen share this bad boy. All right, so 58. All right, so here's 58. If f of x equals 2x cubed minus 3x plus 2, find the average rate of change and the instantaneous rate of change. So the average rate of change, you can always tell you're doing the average rate of change because you have an interval. So what we're going to do is we want f of 3 minus f of 0 over 3 minus 0. Okay, that's those. This is the average rate of change. So we're going to plug in 0 in for x. We're going to plug in 3 in for x. So when I plug in 3 in for x, let's plug that in. F of 3 is going to be 2 times 3 cubed. That's 27 times 2, which is 54 minus 9 plus 2. All right. So that's going to be 47. Okay, so we get 47. So I'm going to put that there. 47 minus. When I plug 0 in for x, I'm just going to get 2. And then divide by 3. So that's going to give me 45 divided by 3, which is 15. So that's the average rate of change. The instantaneous rate of change at x equals 3 is the derivative. Okay, so I'm going to find the derivative. F prime of x is 6x squared using the power rule minus 3. Then I'm just simply going to plug in 3. So I'm going to get 6 times 9 minus 9. It's 54. Minus 9, which is 45. Oops. Okay. So that's average rate of change and instantaneous rate of change. Let's see what we got. We got some 40s here I just saw. Let's look at 41 and 42. I think actually a couple people asked those questions. So let's look at 41 and 42. So on the intervals, so this question is interesting. It says, on what intervals are these functions continuous? So I think what we can actually do is, instead of thinking about where they're continuous, let's think about where they're not continuous. And then when we know where they're not continuous, then it's going to be continuous at everywhere else, right? So it's not continuous at anywhere we get holes or vertical asymptotes or jumps, but this doesn't have any jumps, so we're looking for holes and vertical asymptotes. So we're going to take this and factor the bottom. And so right there we have a hole at x equals 0. Gets me 1 over x minus 1. And then right there, boom, vertical asymptote at x equals 1. So this function is continuous for all real numbers except x equals 0 and x equals 1. So this is how we'd write it. So it's easier to think about on what intervals is it continuous, where it's easier for this kind of stuff. It's easier to think about where it's not continuous and then just saying that it's continuous everywhere else, okay? So like for this one here, where is this continuous? Well, we're just going to check its domain. So this is a square root function, and the domain of a square root function is when the inside of the square root is greater than or equal to 0. So this is where this function is continuous for all values inside its domain, which in this case is x greater than or equal to 2. Okay, hopefully that answered that question. Let's look at 47 and 57. Okay, so 47, this is just finding the equation of a line. So there's no calculus involved in this one. This is just a review problem, except that you should notice that the x's are the same number. So when the x's are the same number, that means this is a vertical line. So it's just simply going to be x equals 1. That's it. That's all you need to do. If you found the slope of that, you're going to end up with 2 minus 3 over 1 minus 1, which is negative 1 over 0, which is undefined. And any line with an undefined slope is going to have an equation of x equals something, in this case 1. $57. Use the alternate form of the limit definition of the derivative. Oh, fun. Let's see if I have enough room here for this. So we've got f of x equals 3x. Okay, f of x equals 3x cubed minus 2, and we're looking for f prime of 3. Okay, so this is number 57. All right, so what we're going to do is the alternate form is the limit as x approaches 3 of f of I believe it's f of 3 minus f of x over, oh, it's f of x minus f of 3, sorry. F of x minus f of 3 over x minus 3. So we're going to get 3x cubed minus 2 minus 3 times 3 cubed minus 2 over x minus 3. And that's going to give us 3x cubed minus 2. 3 cubed is 27 times 3 is that 81? Minus 2 is 79. 77. All right, we're getting a lot of hits here, so everyone's joining in now. Feel like I'm doing something wrong here. Duh. Okay. So, yeah. Minus, okay, so if I get, this is going to be 81 right here, and this is going to be plus 2, right, when I put this in here. So these 2's are going to be gone, and then I'm going to get minus 81 over x minus 3. So then I'm going to simplify that a little bit more. I'm going to factor out a 3, and that's going to be 27. And this is one of those crazy difference to cubes problems. So it's going to be x minus 3 times x squared. X squared. Where was it? Plus 3x plus 9. I don't think that I'm giving you a cubic on the test. So you plug in 3 here, and you're going to get 3 times 3 squared plus 3 times 3 plus 9, which is going to give you your answer of finally 81. So really, the thing you need to know is just, make sure you understand the form, how to put the formula in for the alternate form. And you only use the alternate form when you're looking for a value, all right? Otherwise, the alternate form doesn't help you at all. Okay, let's see what else we got. Got a bunch of people coming in now. Let's see, that was 47. Oh, I said 57. Let's see, we got 57. The one I just did. Okay, so I did 47. I did 57. And all right, so let me just quickly talk, because some people were asking about how do we use the calculator for, again, some of the review problems from Unit 1 will use the calculator that you needed, but the bigger couple of problems that needed the calculator that I know of for this test are the ones where you have to find the limit using the calculator. So let's see, was there any on this where you had to do that? Derivative doesn't look like it. Okay, let me see if I can find a problem that would be similar to that. Okay, so if you go back to 2-1, 2-1 right here, problem number 8 right here. So problem number 8 in 2-1, you're looking at use a calculator to find these limits right here. These are examples that you want to take a look at. So whatever this video is in, it's 2-1. I'm not quite sure if I did that or not, I'll go ahead and do this one right here for you. Okay, B. It's x cubed minus 3x squared plus x plus 2 over x cubed minus 2x squared minus x plus 2. This is the type of problem that's going to be on the test in terms of finding the limits using the calculator. So let me load up the calculator here, and while that's loading up, let me see what else we got coming in. 40, 56. Okay, we'll get to those next. I'm gonna let my calculator load up and then I'll come back to this. Okay, guys. So let me go over 40. So I'm not wasting time here. Okay, so 40 was one of those that I guarantee is going to be on there. So what you're going to need to do for 40, this is 40 right here. All right. This is the one where you have to, these come up a lot. They're on every test. What you have to do is you have to take these, let me zoom in here. You have to take these values, okay, that they have in common, plug this in for each one. All right, so I'm going to plug in one first. Let's see what I got here. When I plug in 1, I'm going to get 1 plus 1, which is 2. And I'm going to set that equal to when I plug in 1 in the other one. So that's going to give me 1 plus A plus B. Then I'm going to plug in the other value that I have. And I'm going to plug that in and set that one equal to. So 3 plus 1 is 4 equals 9 plus 3A plus B. All right, now that I have these two things, I'm going to set up a system of equations and solve those guys, okay? So it's going to look like this. I'm going to subtract 1 over, and I'm going to get 1 equals A plus B, and then I'm going to subtract 9 over, and I'm going to get negative 5 equals 3A plus B. And depending on what kind of method you want to use for this, you can use I saw one student today, they decided they're going to use substitution, so they solved for B. So they said B is equal to 1 minus A, because they subtract A from both sides. Then they take this, plug it in here, so they get negative 5 equals 3A plus 1 minus A. And you get 2A plus 1, subtract 1, 2A, A equals, divided by 2, negative 3. So there's A, and then you plug it back up here, and you get B equals 1 minus negative 3, which is going to give you 4. All right, so they work the same way every time, guys. Every time they work the same way. You plug in the first one into both of them, set it equal to each other. Plug in the second one into each of them, set it equal to one another. Now that you got those two equations, A and B, you got to solve for A and B using a system of equations. All right. Okay, let's go back to the calculator now. I'm going to go to graphs. And I'm going to make this guy bigger so we can see what's going on. And sorry, it is so small. Oh, come on. Let me make sure that it's sharing the right screen. There's me again, guys. Okay. Oh, it's infinite me. Okay, no, I'm just kidding. Okay, so let's get back to the calculator here. So what I'm going to do is I am going to plug in that function that we were looking at just a second ago. Let me get back all the way up here. Here we go. Here it is. X cubed minus 3x squared. So press this thing here. That's what I want. And I'm going to go x cubed plus 3x squared. What was it again? Oh, minus 3x squared. Okay, plus x plus 2. So minus 3x squared plus x plus 2 divided by x cubed minus 2x squared minus x plus 2. Minus x plus 2. Okay, so now that I put that in, I'm going to hit enter and let it graph it. Let's see if I can make this any bigger. Sorry guys, it's very small. It's my computer, it's the resolution on it anyway. Okay, so now we're looking for, what are we looking for? We're going to go back over here and see what we're looking for. We're looking for the limit as x approaches 2. The limit as x approaches 2. It looks like to me, it looks like it's going to be some value right there, right? The limit as x approaches 2, there's 1, and there's 2. So it's going to have some value right here, 2. So what I'm going to do is I'm going to, now if I think it's an actual value, watch what happens though, watch. Let me do control doc, or to get another page, and get a calculator page. And let me do F1 of 2. Just plug in the value of 2. Undefined, uh-oh. Well, that means there's it's gonna approach a number, but there must be a hole in the graph right there that we can't see. So what we're gonna do is we're gonna hit menu, and we're gonna hit table. We're gonna look at this table. And you see that at x equals 2, it says it's undefined. So what I want to do is I want to approach 2 from the left and the right, very, very close to 2. So I have to change my menu, my table settings. So I'm going to go to table or menu table, and then I'm going to go to edit table settings. I'm going to start, let's see, I'm going to start somewhere close to 2 because that's where I want to go to. So let's start at like 1.7. And I'm going to go by 0.04. So each step is going to go 0.04. So let's see what that looks like. All right, so 1.7, we're going up, getting closer to 2. All right, let's see what's going on. 0.36, 0.34, 0.32, 2. All right, so I think I want to get even closer here. So let's start at 1.98 and then go by even smaller values. So I'm gonna go menu. Come on, dude. Menu, table, edit table settings. Okay, we were at 1.98. And we're gonna go even smaller values. So 0.01. See what we're doing here. Okay, we're trying to get close to 2. Oh, there's undefined. All right, so we've got 0.3338 and 0.332. So what do you think it's getting close to? We need to find it to 3 decimal places. So I would say that it's getting closer to 0.333, right? From the left, it's 0.3338. From the right, it's 0.33. I'm sorry, from the left, it's 0.3327. From the right, it's 0.3338. So I think that the limit as x approaches 2 for this one is 0.333. So these are going to be multiple choice questions. So you just got to build this table and see which one gets you the closest to your actual answer. Okay, so you're using the calculator and looking at the table to get really, really close to that value of the limit as it approaches 2. So hopefully a student asked about how do we do this stuff on the calculator, what's on the test. That's what's on the test. So hopefully that helps you out with that one. Okay. Let's take a look at a few more here before it's time to take off. 40. Oh, I did 40. Okay, so hopefully you got that 40. 56. Use the limit definition of the derivative. So for 56, something like that, where f of x is equal to 3x squared plus x, I prefer the limit as h approaches 0 of f of x plus h minus f of x over h. Now, I prefer that one because I think it's a little easier to use. You need to memorize this. You can't get around this without, how do you know what table setting to put? You just got to, dude. Let me go back to the calculator real quick. Somebody asked me, how do you know what table setting? You just have to think about what your limit is, all right? The limit here, when I was doing this one, the question was the limit as x approaches 2. So I'm going to start at a number close to 2. That's why I started at 1.9. And then the setting, I want to get really close. So I'm going to go by little values, 0.01. That means I'm going to go 0.01, then 0.02, then 0.03, then 0.04. I'm going to get closer and closer and closer. And then if I'm not close enough, I'm going to get even closer. That's why the next time I set it at 1.98, which is even closer to 2, and I did a step value of 0.001. So it's even getting closer. So you have to look at this number, okay? So hopefully that helps you on that. That's all I can say about that. I mean, there's not really much more I can do than tell you that's how the step goes for that. All right, what are we looking at? Limit definition. You have to memorize this, guys. There's just no way around it. You just have to memorize things, okay? So we're going to go ahead and do x plus h into that squared plus x plus h into that minus f of x. Don't forget to put your f of x in parentheses over h. And then I'm going to FOIL this guy out here. So it's going to be 3x squared plus 2xh plus h squared. That's this part. Plus x plus h minus 3x squared plus, minus x. Okay, so I'm going to get right here, I'm going to get 3x squared plus 6xh plus 3h squared. I only did that there when I, so I can see that I'm going to end up canceling those out and canceling those out. Whenever you're doing the limit definition of the derivative, you're always going to end up canceling everything out except for the things that have h's in it, because that h needs to cancel out in the denominator. All right, so you're going to end up with you're going to end up with this, this, and this in the numerator. So I'm going to factor that h out, and I'm going to be left with 6x plus 3h plus, factor an h out of an h, we get 1 divided by h. Those get rid of that. Plug in 0 for h, and you're going to get 6x plus 1. That's what's left over. There you go. That's limit definition of the derivative. All right. Let's see what else we got. Hopefully, did I do 44 already? Use a calculator to find the points of intersection of the graph. Okay. You have to solve for y. Solve for y. Plug these in. Two functions. Find the intersection. Write the equation you're solving when you're solving this. 4 minus x squared equals 2x minus 1. Okay. Plug this in for F1, this in for F2. Use the intersection in the menu, and you should be able to find that. Okay. $60. Ooh, multiple 60s. Ooh, multiple 60s. All right, let's see. Determine whether the intermediate value theorem would guarantee a C value on the given interval. If it does, find the C value. If it does not apply, write a sentence explaining why. Okay, so intermediate value theorem, you need to do 3 things. The first thing is check continuity. All right, so f of x, we'll do, we'll try to run through all of these real quick. So for A, this is a polynomial. So the first step is continuity. So we're just going to say continuous on the interval, -1 to -4 to -1. That's right. So we check that off. That's perfect. Second thing is we need to check that when we plug in f of -4 and we plug in -1, those two values, that's this value here, k, is in between those two. All right, so we have to find f of -4. All right, so we're going to plug those in. And we are going to get that math is not that hard for me. I don't know what I'm doing. All right, it's 24. And then you're going to plug in the other one. I think this one comes out to negative 11. And then you're going to check, is 4 in between that interval? Then you go, 4 is, in fact, between 24 and negative 11. Check. Now you do the third thing, which was, so now, since both of these hold, the IVT works. Okay? So since the IVT works now, we can go ahead and find our C value. So what we're going to do now for our C values, we're going to plug in C. We're going to do f of C. So we're going to get C squared minus 4C minus 8, and we're going to set that equal to whatever number was over here, which was 4. And then subtract 4 minus 12, factor. That's going to be 6 plus 2. C equals 6, C equals negative 2. However, we need values that need to be between negative 4 and negative 1. 6 is not one of those values. Only that one works. There's your answer. Has to pass the first two things to even go on to that. So if you notice right here for B right here, x minus 2 cannot be 0, x cannot be 2, because it's not continuous there because there's a vertical asymptote. Well, the problem is that 2, that's in between 0 and 5. So our first one, continuity, doesn't work. So in this case, I would say the IVT does not apply. Does not apply since there's a vertical asymptote at x equals 2. All right, hopefully that makes sense. This one works because x equals 1 is a vertical asymptote, but that's not in this interval. So I can go and see, now I can do step 2 and plug in 2 and 5 and see if this other part works, okay? So that's how you deal with the intermediate value theorem. Okay, we got time for a few more. Took it 68. I'm not sure I can do all of these. I will post up the solutions right now because I totally forgot to do that today. So, or did I do that? I'm not sure, but I'll go back and check. If I didn't do that, then I'll go do that right now. But let's just talk about a few of these really quickly. So the first thing you should always do is simplify if you can. So we can simplify here and here, here and there. And since we totally eliminated this part and this part, okay, since when we simplify, Fred, function reduced, is going to be x plus 2 squared times x minus 1 over x plus 1 times x minus 2 squared. Since we eliminated the x minus 1 and the x minus 3 from the denominator, we have holes at 3 and x equals 1. Now I have to plug those into my reduced function there. It looks like if I plug in 1, I'm going to get 0, because 1 right here, 1 minus 0. And it looks like if I plug 3 in, I'm going to get 25, 50, 50/4. I'll just leave it like that because, you know, who needs to simplify? The domain is going to be a bunch of stuff here. So I'm just going to write it out here. X cannot equal 3, x cannot equal 1, x cannot equal -1, and x cannot equal positive 2. Where do I get all those? I get those from here. Those are vertical asymptotes. And I get those from my holes. Okay, that's where I got the domain. For the x-intercepts, I put all the stuff that's on the top, x plus 2 squared, set that equal to 0, x minus 1, set that equal to 0, and the x-intercepts are going to be at x equals 1 and at x equals -2 when I solve these guys. Okay, my end behavior, I'm looking at my horizontal asymptotes, right? So my horizontal asymptotes, I'm going to have x squared, x cubed down here, and x cubed up there. So I'm going to have y equals 1 as a horizontal asymptote, because I'm going to end up with x cubed over x cubed when all is said and done. And so that's 1 over 1 since the powers are the same. And my y-intercept is when x equals 0. So I'm going to plug in 0 for x for everything. And I'm going to end up with, well, whatever I end up there with. You can plug in 0 and figure that one out. Okay. Quickly on some of these other ones, there's no way to reduce this guy. All right, so that is what it is. And same here, there's no way to reduce that guy, that it just is what it is. So the f reduce is just, it is what it is, right? Can't reduce it. So the only thing, so again, end behavior equals horizontal asymptotes. And behavior equals horizontal asymptotes. And behavior equals horizontal asymptotes. So go back and look at the rules for this. Little over big, big over little, and then same. All right, little over big is going to be y equals 0. Big over little, none. Same. Coefficient divided by coefficient. Okay, so if it's asking for the end behavior, it's asking for the horizontal asymptotes. If there are no horizontal asymptotes, so you get none, you got to do a little analysis and see, is it going up like that or is it going down like that? Is it going to negative infinity or is it going to positive infinity? Okay, so again, end behavior, horizontal asymptote. X squared and x, right? X squared, and x is going to give you x cubed. X and x squared is going to give you x cubed. And so x cubed over x cubed is just going to give you 1. That's why the horizontal asymptote is 1. All right. Now these, I'll talk about the end behavior of these because these two are a little tricky. You've got square root of x squared. So that's going to end up being an x, right? That's actually an absolute value of x. And then this right here is going to be an x in the long run, like as we go out to infinity. So end behavior is going to be as we go out to positive infinity. Since I have an absolute value over x, that's going to be positive 1. So whenever you have this type of thing, you have to look at the signs. This is always going to be positive. This is going to be positive if your infinity is positive. It's going to be negative if your infinity is negative. So as we go out to negative infinity, this is going to be -1. So this one is a bit tricky because this has 2 horizontal asymptotes. This one also has 2 horizontal asymptotes, except now you have a negative x on top, and then the absolute value of x on the bottom from this square root. So now the end behavior of this bad boy is going to be just like this one, only backwards. So it's going to be as it approaches positive infinity, it's actually going to be -1 because this is going to make this right here is going to make it negative as I go to positive infinity. And then as I go to negative infinity, it's going to be +1 because, you know, negative times a negative is a positive. So that one is a little trickier. Okay, guys, I've gone over a lot of stuff. I'm going to go ahead and put in the solutions on Google Classroom so you can take a look at that. I know it was a short amount of time. Hopefully it helps for those of you that came online and saw what you needed to do. You can let me know if it helps on Monday after you have taken the test. Okay. Hopefully it goes well. I think it's going to go well. You guys be confident in your abilities because I'm confident in you guys. And I know I say that to you a lot. And you guys often tell me, "Oh, you think you're way too more confident in us than we are in ourselves." Well, that is true. So I'm just asking you to be a little more confident in yourselves and be ready for the game tomorrow because that's our game. And you guys will do well. I know it because I've been seeing what you're doing, and I'm always amazed at you guys this year. You're doing phenomenal work. And so just try to show me on this test what you know so far. And that's all I'm asking. Because remember that as we move along in the course, you get to build on your knowledge and you can always come back and build it and get better and get better and get better. So good luck tomorrow. And we'll see you tomorrow. Good luck, guys. Bye.